Assalamu alaikum, everyone. Today, first of all, I would like to congratulate you all for coming this far. We are almost halfway there. In fact, we are halfway there. This is the fifth week and 16th lecture for CS 116 Object Oriented Programming. So let's get started. Last week, we had been discussing inheritance. We saw the basic syntax for inheritance and we did several examples. We discussed method overriding in detail, how these can be used to override or extend functionality of a parent class. And then we discussed multiple inheritance and rules for method searching in multiple inheritance hierarchy. In the end, we also discussed association and we compared these two approaches. Like like sometimes you have a choice that instead of inheritance you can choose association. So both of these approaches, they have their own pros and cons, and it's a design choice which option we go for. In today's session, first we'll recap the concept of polymorphism as discussed in lecture 3 of week 1. There we saw that this polymorphism exists in three forms: method overloading, method overriding, and operator overloading. And out of these three, we have already done method overriding because that was actually tightly coupled with inheritance. So we studied that last week during last 2 weeks along with inheritance. So in today's lecture, we'll see operator overloading. And after this, one more thing that we need to discuss in polymorphism is abstract classes. We'll be doing that in the next 2 sessions. Okay, this is from lecture 3. Polymorphism is, there we define polymorphism as a Greek word meaning occurring in different forms or many forms. And there we also discussed that in programming languages, polymorphism exists in different forms, and mainly it means that a method or an operator, it can be used or it can exist in several different ways in the same program or in the same class. We also discussed that polymorphism exists in three forms in computer programming. Operator overloading, which enables a programmer to change meaning of an operator. That means an operator can be used in several different ways in a program. Method overloading means that we can define more than one methods having same name in the same class or same program, and one of them is dynamically chosen when the program runs according to the parameters that we provide to that method. And the last one is method overriding. Method overriding means that two methods can have same names, but they exist, one of them exists in a child class and the other one exists in the parent class. That means the child class method can override the functionality of its parent's class method. Now let's see these three concepts in context of Python. We have already discussed that method overloading is not needed in Python because why we need method overloading in the first place, or why programmers need? Because in method overloading, what we do, let's suppose a programmer has defined a method having two integer parameters. So if he wants to use the same method for float parameters or a string parameter, what he'll do, he'll just overload that method. That means he'll write that method again, providing or using different types of parameters, and that's how what the compiler will do, it will choose the appropriate method at runtime depending on the types of parameter the user provides, right? So that is not required in Python because Python supports dynamic typecasting, and you can supply any kind of parameter to a method, right? As long as it satisfies or it works well with the internal code of that method, that is absolutely fine. Like Python doesn't restrict you to force restrictions on the type of parameters you are passing to a method, right? So that's why method overloading is not required. The other thing is that you can use different methods if you want to change the number of parameters. That can also be solved in Python using that arg argument. If you recall from last semester, we studied how we can define variable length arguments, that steric arg notation or steric or any variable name notation that allows you to pass as many arguments as you want from the main class, or from the, sorry, from the main program or the calling program, right? So that means we do not require method overload, or method overloading's implementation is not actually required in Python, because uh, Python supports all those things automatically, which usually programmers do in other language, or programmers achieve in other languages through method overloading. So we don't need to study this method overloading in context of Python. Apart from this method overriding, we have already done this during last 2 weeks, right? We have seen how we can override parents class method. Now the only thing remaining is operator overloading. So this is the topic of our today's session. And one more thing which we'll discuss under this heading of polymorphism during this week is how you can make abstract classes, right? So we'll come to that in remaining 2 lectures. Right now, let's discuss what operator overloading is. In fact, we know what operator overloading is. Let's see how it can be implemented. Now, we already know the basic definition of operator overloading. What we can do, we can implement, or we can provide functionality for an operator in a user defined class. Like we can provide some custom functionality for an operator. Now what comes under this operator's definition? It could be some expression operator, like it could be some arithmetic operator or comparison operator, like plus minus, greater than, less than, equal to, or it could be some assignment operator like plus equal to, minus equal to, etc, etc. We'll see that later in today's lecture. And one more thing that comes under this operator overloading is that we can overload some operations, built-in operations as well. And we had been doing this during last 2 weeks. We overrided that init method and str methods. That comes under this point. That means we were overriding or overloading some built-in operations, and we were giving our own custom implementations for them, right? So that is sometimes also, in fact, that is also counted as operator overloading. Overloading makes class instances act more like built-in types. Like if you want a user-defined class to behave in a similar manner as that of a built-in class, there that can be done using this operator overloading. For example, integer is a built-in class, and if you want to add two integers, you just use that plus sign, like 3 plus 4. You don't have to write or call any method for this purpose. You just use this operator, and that really looks nice and easy to understand. So if you want some of your class to act the same way, like you don't want to call a method, instead you want to use some operator to implement a functionality, that can be done using this operator overloading, right? So if you overload operators, arithmetic operators or comparison operators, that will make your class more user friendly, right? We'll see that today. In fact, that's the topic which we'll be discussing today. Okay, overloading is implemented by providing or overriding specially named methods in a class. This is what we have already seen. While we were working with init method and str method, what we were actually doing, we were overriding some dunder methods. And dunder are the methods which are automatically executed by Python on certain instances. So what we had to do in order to override some functionality, in order to overload some operation, you just have to override those methods. So same is the case with arithmetic overloading, arithmetic operator overloading or comparison operator overloading. We see that there are special methods. We just have to override those methods to implement this particular functionality. Okay, this is what we had been talking about, that operator overloading is done through method overriding, or we just override dunders to implement an operator for our class. And what happens when we do this, your operator can act in a specific way like you want it to. For example, we have seen plus operator, and it is used in different ways in different classes. Like in integers, it is used to add two integers. It just gives us the sum. Whereas if you use this plus operator with strings or lists, it simply concatenates those any two strings or any two lists, right? So that means this operator has been overloaded in different classes. It is used in different ways in different classes. So we can also overload this operator uh, in our own user defined class, and we can have some custom functionality for this. So what happens behind the scenes? Whenever you use an operator, it invokes a method at the backend. That's what dunders do. They are invoked at specific instances. So whenever you use an operator, it calls actually a dunder method at the backend. So let's take an example. Let's suppose you are writing this algebraic expression x plus y. So when you write this expression, what happens at the back end? This expression, it is decomposed into this method called given on the right, x dot double underscore add double underscore y. Now you can recognize from the syntax that double underscore add double underscore is a dunder method. That means it's a special method that is called when plus operator is used. So whenever you use this plus operator in any code, Python calls this method, this dunder method add at the backend. And what happens out of these two operands, x plus y, there are two operands involved in this expression, x and y. So what happens? This method is invoked on one of these operand. Like in this case, x, or the the leftmost operand has been chosen on which this method has been invoked. So x dot double underscore add double underscore y, and the second operand is passed as an argument to this method, right? So that means x class or class to which x belongs, it must support this method, or it must provide implementation for this method add, so that it can be invoked whenever you use this plus sign along with x, right? So in short, whenever you write an arithmetic expression like this using these operators, that expression, it's first translated into some method calls, and then those methods actually are providing the functionality that we require in that expression, right? So just keep this in mind, and this will help you implement these dunders in a simpler way. So this is a very simple concept. So let's see some examples for this. This is the first example. We just discussed that plus is an overloaded operator in many classes. Like it can be used to add two integers. It can also be used to concatenate two strings or two lists. But if you provide, one string and one integer argument with plus, that doesn't work. So in our first example, I'll make that work. So this is our problem statement. We'll define a class known as my_str. It will have one instance variable strg. It is not mentioned here, but I'm going to take it as a string, right? And what I'll do, I'll override this plus operator for this string so that I can concatenate any type of object to this string. For example, if the string is xyz and I write xyz plus 1, I should get some answer. I should not get some any error, but I should get some answer. So let's do that here. Now, the first thing that you need to think about while implementing such operators is that how you want your output to be. For instance, let's suppose I have this string ABC and I concatenate a number, let's suppose 2 with ABC. What I want? Do I want concatenation, like I want output to be ABC2, or I want ABC to be printed 2 times? That's what happens in when you use that steric operator with strings. It simply repeats that string 2 times. That means it overloads that steric operator for that specific functionality. So what point I want to make here is that first of all, you have to decide when you use this plus sign with this string ABC, what you actually want at output. So here, for simplicity, this is the output that I want. Let's suppose if I concatenate x with 3, x is an instance of this my string type, and if I concatenate x with 3, 3 is an integer. So I'll just convert this 3 to string, or I'll typecast this 3 to string, and I'll concatenate it with X. This normally doesn't happen in Python. Python doesn't support this kind of concatenation, but we'll write code to implement this. And this is what I told you on the last slide, that whenever I'll write this x plus 3, this will actually decompose into this method called x dot double underscore add double underscore 3. So that means 3 will be the parameter, and I have to convert it or typecast it to string, and then I simply have to concatenate it with x, and that concatenated value will be returned by this method. Let's start writing code for this. This is my class mystr. I'm writing an initializer for this. I have to define one instance variable strg. So this initiator will simply initiate this strg instance variable to any value s passed by the user, and if the user doesn't supply anything, strg will be initialized to an empty string. Those two, single quotes means it's an s. The default value for s is an empty string, right? Now let's come to the main method. Now I have to overload plus operator. For that, I have to override the dunder double underscore add double underscore. And as we saw on the last slide, the format will be that user will pass any object, and that object we have to concatenate to strg. So self is the essential argument, essential first argument for instance methods, and any object will be representing any object passed by the user. So what I have to do, I simply have to typecast this any object to str, and then I have to concatenate it to strg and return it to the user. So this is the simple statement. Self.strg plus is already supported for string types, so it will concatenate two strings. So what I have to do, I just have to convert this any object or typecast it to str and add it to self strg. Let's test this. Here I am initializing x as an instance of my str class to Python. Now if I write this print x plus programming, so what I am actually doing here, x plus programming means that I am calling this add dunder on x, and I am passing this programming in place of any object, that parameter any object. So there is nothing new in it, because programming is already a string, and we could have done that without using this class. This is the output that should be there, Python, and programming will be concatenated to it. Okay, now let's suppose if I do this x plus 3. X plus 3 means that I'm concatenating x, which is a string, with 3. So now here actually x is not a string, but when I write x plus 3, what will happen? The string instance variable inside x, it will be concatenated to 3. So x dot strg is equal to Python right now. So plus 3 means Python 3 should be printed. Here it is. Similarly, I can concatenate a float value, because I can pass any object. I'm just typecasting it to str. So this will print Python 3.7. And I can even pass a list. And this list will be converted to string and concatenated to x.strg. And here it is, right? So that means that we have overloaded, or we have provided our own implementation for this plus operator, and that's how we can use it. Now let's do another example. It's a more realistic, or we can say a more complicated example. Here I'll define this point class. Actually, we have already defined this class in some previous lectures, and it was a very simple class. And this class actually was used to define a point in a 2D plane. That means that point can have two coordinates, an x coordinate and a y coordinate. So there were two instance variable in this class, x and y, and we had defined a set of methods for this. First of all, setter methods, set x and set y, are setter methods for x coordinate and y coordinate respectively. Then Okay, there last time we defined, I think, a getter method because we had not seen method overriding till then. So there we defined a getter method to display value of a point, like value of x and y coordinates of a point. But now we know that we can override this str method and we can directly print an object. So this is the first change that we are making to this class point. So we'll define str method instead of that getter method. This is the old method move. It will simply move x and y to x plus dx and y plus dy. And this is the new thing. We'll override this plus operator for our point class. So uh, what it can possibly do, if I write p1 plus p2, and p1 and p2, they are both point type objects, then what I would expect this plus operator to do, I will simply expect it to add corresponding coordinates, like x of p1 should be added to x of p2 and y of p1 should be added to y of p2. So let's write code for this. Okay, this is the class that we have to implement. Now, out of these 6 methods, first 5 are really simple. We have done that so many times, so I'll just go through that code quickly so that we can come to the actual, that operator overloading method. I'm defining this class point. First of all, I'm initializing these through initiator method, initializing x and y instance variables through this initiator method. That's how we can do this. Then I'm defining these setup methods. I don't think that I need to explain these right now. Such implementations, they have really become, simple now, since we have studied so many other things also. Okay, str, I just want this point to be printed on screen in some way. So let's suppose this is the way. I'm just putting these angular brackets before and after these 2 points. So starting angular bracket, x value, comma, y, and then ending angular bracket. So that's how I want my point to be printed on screen. And this is the move method. This is also self-explanatory. Now let's implement this dunder. As I told you earlier, first you have to think about like what kind of output you want as a result of this. Like whenever you are using this plus operator, what you want output to be. Let's suppose if I write p1 plus p2, and p1 and p2, they are both of point type. What will happen, this method will be called on p1, on the leftmost side operator on p1, and p2 will be passed as a parameter as shown here. So if I am writing p1 plus p2, what I am expecting that x coordinate of p1 will be added to x coordinate of p2, and y coordinate of p1 will be added to y coordinate of p2. So that's what we have decided. Now how I want that result to be printed on screen. So this is one way. Simply I'm adding the corresponding x coordinates and the corresponding y coordinates. So what will it print on screen, or what will it actually return to the caller? I hope most of you would have guessed it. It will return a tuple because you are returning two values. So those two sums, self.x plus p2.x, and the second sum, self.y plus p2.y, these two values will be placed in a tuple, and then tuple will be returned to the calling program. So whenever you write p1 plus p2, this program will print the corresponding sums in a tuple form, right? So this is one way of producing an output. Like you could have chosen this way of returning a value. Now what could be an alternate? I can return this value as in the format that we used in str method. This is that format. In str, how we were printing our point? We were printing our point in between these angular brackets. So you can use this format also. That's actually, I have commented it out here. That means this is an alternate to the first one. Either you can return the first statement that will print in one form, and if you use the second statement, that will print in second form. And this second form, since it is similar to the one that we defined in str method, this can be achieved using another technique also, and that technique is this. Here what I am doing, I am instantiating a point type object. You see, return point. Now here point is the name of the class, and actually what I am doing, I am instantiating a point type object, and I am initializing that point type object to these new values like self.x plus p2.x and self.y plus p2.y. So that means this statement, it will call the initiator method, and it will initialize or instantiate a new point with these two values, right? So that means in this third statement, if I use this will return a point type object to the caller. So you see, these three return statements, all of them, they are returning different things to the caller. So it's up to you what kind of output you want. So in the first statement, a tuple will be returned. In the second statement, this notation using these angular brackets, that will be returned. And in the third statement, a point type object will be returned. So it's up to you what you want. uh, One thing you should note here, that this third statement, if you print that returned value, that will produce the same output as the second one, because the second one is similar to, str's implementation. So if you print this third statement, or the point returned by the third statement, that will be printed actually by str. So that will be the same format. Now let's quickly run some test code. I'm initializing a point to 1 5. I'm initializing another point p2 to 2 2, and let's suppose okay, let's print these values first. It should print 1 5. This is that angular bracket format implemented by str method, and here I am printing p2. So this is the value of p2. Now if I execute this p1 plus p2 and I print this, right now I'm considering the first return statement where it will be printed in the form of tuple. So what will happen, this p1 plus p2, it will be decomposed into p1 dot and double underscore add double underscore p2. So p1 will act as self, and p2 is actually p2. And since the first return statement is executed, it will return a tuple, and here is the tuple. You can try out the other two statements also. You just uncomment them and comment the first one, and then see what output you get in that case. So that was pretty easy. We just saw that we just have to override a dunder in order to implement or provide implementation for an operator. So there's a whole list of such operators that can be implemented in your program. I'm listing a few here. Here are first I'll show you some arithmetic operator. This is the plus operator, which we have already discussed. This plus operator, the operation that you will call is x plus y, and that x plus y will invoke this particular dunder, x dot double underscore add double underscore, and y will be passed as a parameter to it. We just saw that. And this will implement addition operation for any user defined class. Not actually addition operation, or whatever, like in whatever way you want to implement it, you can do that. Similarly, you can override or overload subtraction operator, multiplication operator, division operator. This double slash operator is quotient operator. This is remainder operator, and also the power operator. That means all arithmetic operators, they can be overloaded. Similarly, you can override comparison operators too, and here is a list of those comparison operators and their corresponding dunders. Less than, that's the dunder name LT. GT is the dunder for greater than. LE is for less than equal to. Similarly, here's the one for greater than equal to. And equality operator, it actually compares or checks for equality. And lastly, this not equal to operator. Similarly, here is a list for assignment operators. This is the first one, plus equal to. We already know how these assignment operators work. If I'm writing x plus equal to y, that will decompose into x is equals to x plus y. So this operator will actually add these two values x and y, and it will return a value that will be assigned to x. This is a similar assignment operator for subtraction. This is for multiplication and assignment, division and assignment, finding quotient and assigning it to x, finding remainder and assigning it to x, and lastly this power operator assignment. Similarly, here is a list for unary operators. Unary operators are those operators which work with only one operand. Like here, if you see the operation, this is minus x. So what does it do whenever you place a minus sign with any integer or any float? It simply negates that value. You put it to negate a value. So this is called unary operator because this minus sign, it works on just one operand. The operators that we saw on the previous slides, they were all binary operators. By binary operator, I mean that each of them required two operands for operation, right? If you are adding two values, x plus y, x and y are the two operands. If you are comparing two values, you require two operands. So those were called binary operators, and this is minus x is a unary operator. Similarly, if this is another unary operator, plus. Uh, this is invoked whenever you write a plus sign with any object. So that's the corresponding dunder for it. And this third one is for inversion. It works with Boolean values. Like if x is equals to false, then inversion will make it true. Or if x is equals to true, inversion will make it false. So these are all unary operators. At the start of this lecture, I told you that apart from operators, you can also override operations. So here's a small list of such operations that we have already used. We have overrided this method in it. We know how to use it or when it is called. We have also overrided this method, str method. We know that this is executed whenever an object is printed. We have not used this repr. Actually, it is similar to str. In fact, it is used for printing an object at all the places, including the print statement. Whereas str only prints an object whenever you use print statement or you are printing to a file. So they are almost similar. We might use this second one at some place if we need it. Otherwise, for now, str is enough. And this last one is a new one. I hope you can recall this function length from last semester. It is used to find length of a collection. Like if you pass a list to it, it just returns you the number of element in that list, or number of elements in a tuple, or number of elements in a dictionary. So you can provide implementation of this method for your own user defined class if you want, by just overriding this dunder length. Again, this is not an exhaustive list. Okay, we are missing one here. We also implemented the delete dunder, which is called when an object is deleted. So we have used a couple of these previously, and there is a long list. We don't need to study them all. You can always see the explanation, and now you know how you can implement it, or how you can use these operators and operations. So we'll just discuss the newer ones whenever we need them. Now let's quickly see one more example. Let's override this assignment operator plus equal to. Okay, I'll implement this for the same point class. So if I'm writing p1 plus equal to p2, and p1 and p2 are two point type objects, then this statement will decompose into this statement on the right hand side. P1 is equals to p1 plus p2, right? This is the corresponding dunder method that will be called I add. And what will actually happen? when I write P1 plus equal to P2, it will decompose to this statement. P1 is equals to P1 dot I add P2. So that means this dunder method should return a value which is appropriate for assignment to P1, right? You see on the left hand side, this assignment P1 is equals to, and then uh, actually P1 will get the value which will be returned by this method. We are not doing that assignment. That assignment will be done automatically because assignment is part of this statement, right? So what I want you to note here is that here we do not have a choice like what we can return from what we should return from this method I add, because whatever we return, that will be assigned to P1. So that means we should return a point type value so that it can be easily assigned to P1 without causing any issues. So in last example, when we were implementing simple add function, there we had choice, how we want to return the value that will be printed at the output. But here, because there you can assign the result to some point type variable, or you cannot assign that result. So it was up to you, like how you wanted the output to be. But here you do not have a choice. You have to return a point type value from this method I add so that Python can assign it to P1. So let's see how we can do that. Here's the class. All the other methods, they remain same. I am adding this new method I add to the same class. Now what we had decided that a point type value should be returned. So this statement, what it will do, it will add P1 to P2 and it will assign the result to P1 again. So that means I can use P1 here. So you see, I have set this x coordinate of P1 to this new value, and then y coordinate of P1 to this new value. Actually P1 will be represented by self, and then I am returning this self. That means here I am returning a point type object, right? Now this whole thing can also be written as this, right? Now here, what's the difference? Here I am not changing P1 in my method. Whereas in that left hand side implementation, I had changed P1 because it doesn't make any difference. Ultimately this statement will change P1, so I can change P1 by myself as well. But this statement on the right hand side, what it's doing, it is instantiating a new point type object, right? And it is assigning those values to this new point type object, and that point type object will be returned to the caller. Now in any case, we are returning, the important thing is that we are returning a point type object, and that will be assigned to P1. In one case we are overriding P1, and in the other case we are instantiating a new point, and then we are returning it to the caller, and that will be assigned to P1. So ultimately P1 will get changed in any case. So let's define a point P1 and a point P2 and call this statement P1 plus equal to P2. So what it should produce, what output should it produce? It should produce 3, 7. Okay, that statement is actually not printing P1, so I'm printing it explicitly using this print statement, and this is the output it would produce. So this is what we have done today. We learned today how to overload an operator, an arithmetic operator, or an assignment operator, or a comparison operator. We'll see more examples of these in upcoming lectures, but now we know how to do that. We simply have to override the corresponding dunders in order to overload an operator. So that's all for today's lecture. Thank you.